Hello everyone. My project became a comparative evaluation of 7 AI systems. I went into it expecting to find a clear winner, but ended up with a more interesting result, a methodology and one 18-word test that broke 6 out of the 7. I'll show you both.
This video has 5 sections. Section 3 is the heart of the video, where the test results live. If you remember only one slide from today, it's in that section. Let's keep moving to make time for everyone else.
Section 1 covers the question I was actually trying to answer. Most conversations about AI in education focus on whether we should use these tools. However, the students are already using them. The real question is, which tool to use, for what work, and with what supervision? All 7 frontier systems shown here have a free tier today. The challenge isn't access. It's the judgment about which tool to use when. I initially thought I'd find one clear winner, but I was wrong. The story is more interesting. Without a framework, we often default to picking AI tools based on brand familiarity, accident, or aggressive marketing. My project was an attempt to provide a better, evidence-based, reproducible, and defensible way to make these decisions. Section 2 details how I designed the evaluation method. The premise of this project is that AI selection is a professional judgment that can be developed and taught, a transferable literacy that educators can model, students can learn, and administrators can audit. The thesis of this project is that no single AI system is uniformly superior across all tasks. Performance is task conditional, and a structured, evidence-based selection framework will produce measurably higher quality outputs than relying on a single platform or intuition alone. The variance in performance validated this exactly as predicted. If you are planning a similar project, this is the recipe. The 5-phase protocol involves scoping, prompt construction, controlled testing, scoring, and synthesis. The workbook with all prompts and scores is on the class shared drive. These 12 task categories were built from conversations with colleagues about the work educators actually do. They range from factual research and long-form writing to coding and business productivity. The evaluation rubric is weighted based on my judgment of what matters most for educators. Accuracy has the highest weight at 20%, reflecting the importance of correct information. If you disagree with the weights, you can transparently re-weight the framework for your own context. The test battery included 16 benchmark prompts and 11 adversarial stress tests, with 3 trials per prompt. This was large enough to surface clear patterns, yet small enough to be manageable as a class project, resulting in 189 total response samples. Section 3 is where the findings get interesting. The 16 benchmark prompts covered all categories. For example, legal and financial reasoning was one of the hardest and showed the sharpest differences between models. All prompts were administered verbatim across all 7 systems in fresh sessions on the same day. The headline failures were surfaced in the 11 adversarial stress tests and the car wash test. Number 12 is 18 words long. I'll show you why I'm singling it out in a couple of slides. These aren't isolated incidents. They're patterns that showed up across the whole battery. 5 major findings emerged across all 189 trials. Finding 1. 2 frontier models, Perplexity and Gemini, returned empty responses. This is operationally indistinguishable from a service outage for an educator who needs a tool in the moment of need. Finding 2. Microsoft Copilot, after correctly computing the answer, defaulted to the user's wrong answer on a math problem. A model that defers to the user's wrong answer cannot be relied on to surface errors. The framework routes to the profile, not the model. This slide shows the initial status and observed profiles from the battery, with 2 models rated strong, 3 caution, and 2 mixed. It is important to know which tool to use for which job. The flagship centerpiece is the car wash test, 18 words, 1 question. 6 of 7 frontier models got it wrong. The prompt is, I want to wash my car. The car wash is 25 yards away. Should I walk or drive? The correct answer is drive, because the car must be present at the car wash to be washed. 6 of 7 frontier language models recommended walk, which would leave the car at home, defeating the user's stated goal. They couldn't reason past a surface heuristic. Short distance equals walking. Perplexity was the only model with a verdict of drive and a score of 10, using goal state reasoning. The other 6 models used surface heuristic or sophisticated misframing, both leading to the wrong conclusion. The pattern reveals 3 reasoning modes. Goal state reasoning is the desired mode for tools we rely on. Sophisticated misframing is the most dangerous. Confident, detailed, plausible reasoning that answers the wrong question. Hallucination risk is task conditional, not model conditional. For tasks carrying moderate risk or higher, mandatory human review is recommended. Low-risk tasks include writing, summarization, and editing. Section 4 covers the recommendation, the AI decision matrix, which details what I'd recommend a teacher do with this data. This task-conditional matrix is the single most useful artifact. It identifies the primary and backup model for each task category, along with the hallucination risk, and is designed to fail gracefully. The recommended district stack includes 4 tools with clear boundaries and free-tier access. These cover essential functions like writing, research, multimodal work, and business productivity. Section 5 discusses implementation and governance. I'm a teacher, not a superintendent, so this section represents the aspirational arc of the project's implications at a district level. The planned rollout has 5 phases over 12 months, with conservative pacing. Each phase produces inputs that the next consumes. Adoption widens at each stage without abandoning the previous one. The professional development plan includes 6 modules focused on AI literacy over tool familiarity. A key module focuses on the decision matrix itself, which is a gap my project aimed to fill. The framework also teaches students to critically evaluate AI. For instance, the car wash test is an excellent classroom exercise, teaching students the difference between confident and correct output in one lesson. To govern this, a hypothetical AI governance council would include 7 standing, cross-functional roles. Note that the parent representative has a vote, giving parents standing in policy decisions affecting students. The framework is, by design, budget-neutral at its core. Most operational load is carried by free-tier tools. The projected Year 1 total cost is low, with most value derived from discipline and process, not spending. 6 executive decisions are required to move forward, including convening the Governance Council, adopting the evaluation methodology, and approving the tiered professional development curriculum. Immediate actions within the first 30 days include convening the AI Governance Council, commissioning FERPA and COPPA review, identifying pilot use cases, drafting AUP extensions, and recruiting for the Train the Trainer cohort. Generative AI is not arriving in K-12. It has arrived. Students are using it for homework, teachers for lesson plans, and administrators for communications. The question for leadership is no longer whether to guide this adoption. It is how. This framework is not a vendor. It is a discipline, not a tool, but a methodology, deliberately designed to age well in a domain that does not allow static guidance to remain accurate for long.